I need you guys to write down, okay, is highlight tangent circles, because that's what we're discussing right now. And write a little note to yourself that they share, tangent circles share a point of what? Tangency. Okay? So I want you to draw that point for each of these circles. So the point of tangency would be right around here, and the point of tangency for these two circles would be right around here. We are on slide 12. Any questions? All right. Tangent line to circle theorem, okay? In a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at the point of tangency, okay? So, you can only be tangent, right, if when you draw the radius from your point of tangency to the center of the circle, that is a perpendicular line to your point of tangency, okay? So all we're going to add here is a perpendicular mark right here, okay? So anytime you draw a perpendicular mark from your radius, created by your radius, and your tangent line, that means that your line is tangent, okay? Now, is this radius, if we drew a radius over here, is that one going to be perpendicular to this tangent line? No, okay? Because first of all, they're not even going to intersect, right? They're not even going to have a point of intersection. And secondly, like this point of tangency is it's only going to have one radius that will be perpendicular to the tangent line, okay? So it has to be, but in order for this to be a tangent, it needs to be perpendicular. Okay. Perpendicular, a right angle, okay? Second thing that you guys need to know, okay? If you have any point outside of a circle, okay, there are going to be two lines that you can draw that will be tangent to the circle stemming from that point, okay? So we're going to start with point B. Do you guys agree that going to point A and to point C, those are the only tangent lines that we can draw that connect with point B? The distance between A and B and A and C will be the same. Okay, and that's any point that lies outside of your circle. Okay, the distance between A and B and B and A and B and B and C will be the same. Okay, so just for me, please draw another point over here and label it D. And to the best of your abilities, draw the two tangents to the circle. So go from D to somewhere over here, and we'll call that E. And then do another point right around here to D, and call that F. What two segments would be the same length, guys? Xavier?
DF and DE.
DF would be the same as DE. Very good. Okay? You can throw some two congruence marks on there. Okay? Now, this only works for a point that lies outside your circle. Does that make sense, guys? Okay? And those two lines are tangent to the original circle. Cool beans? Okay. I can never remember the external tangent congruence theorem, okay? I just call it the ice cream cone theorem, because I feel like when you draw this, you make an ice cream cone. And yes, you can use the ice cream cone theorem on your exams as proof of the theorem, okay? So if you want to use it as the ice cream cone theorem, feel free to use it, okay? Ice cream cone theorem. Yeah, Christian? 11-11, baby. Okay, any questions on either of those two theorems, okay? So, a tangent, right, to our circle makes what kind of angle with the radius?
Ice cream. What?
The first one. And the ice cream cone, the two sides of the ice cream cone are the same length, right? So this segment is the same as this side of the ice cream cone. Cool beans? All right. So, is ST tangent to the circle P? Is ST tangent to the circle P?
Yeah.
Okay. Now, we have to figure out how we can prove it. Okay?
Oh, yeah.
What would need to be true if ST was tangent to our circle?
Oh, no, not tangent.
What would have to be true if ST was tangent to the circle? Gabby?
It'd have to be
But remember, this one, is this
Oh,
a
yeah.
tangent? What'd you say?
perpendicular.
Very good. It has to be perpendicular to what line?
TMP?
Correct, because TP is what kind of line in our circle?
Radius.
It's a radius, okay? So a tangent and a radius form a 90-degree angle, right? So all we need to check is that this triangle is what kind of triangle? A right triangle.
But it's not.
So we can check it, right? What would A be in this triangle? Because we're going to use A squared plus B squared equals C squared, right? That's how we check. That's how we check a right triangle, right? So what would A be?
12.
12. What would B be?
35.
And what would C be?
37.
So A squared plus B squared, we're comparing that to C squared, right? Because as long as this is a right triangle, then we know ST is tangent to our circle. So A squared is 12, 12 squared, plus B, which is 35 squared. We're comparing that to C, which is 37 squared. I know it's 12 squared, but I don't know 35 or 37 squared. This is 144. What's 35 squared, guys? $1,225. And what's 37 squared? 1,369. Oof. Do they give you the same thing? They should. I think. Yes?
Yeah.
So if they're equal, what does that mean about our triangle?
It's a right triangle.
It's a right triangle. So therefore, the angle that's created at point T is how many degrees?
90.
90 degrees.
Wow.
So yes, ST is perpendicular to PT, therefore ST is tangent.
So cool.
Okay? In the diagram, point B is a point of tangency. Find the radius R of circle C. Okay? So, do you guys agree that this would be a radius up here, and this would be a radius down here? So, we're still dealing with a right triangle, right? Where our right triangle is happening here, because it said it's a point of tangency. Agreed? Point B is a point of tangency. So, we're dealing with a right triangle. What would our A side be? R. What would our B side be?
80.
80. And what would our C side be?
50 plus R.
50 plus R. Very good. That's going to be equal to C. Okay? So we're going to take A squared plus B squared, set it equal to C squared so we can figure out what R is. What was A?
R.
R, so we square it. What was B?
80.
80, and then you square it. And what was C?
50 plus R.
50 plus R. But look, we square it. You guys, when you square a binomial, which is a two-term, what's in parentheses, right? We've got a two-term polynomial. You do not square the first term and square the second term. You have to use what we call FOIL. If you forgot how to FOIL, I need you to go back and Google it tonight, okay? So write a little note to yourself. We are going to use FOIL here. This is an algebra skill that you guys need to know for this lesson because there are going to be problems like this. A problem like this. So when we FOIL, check it out. We write it down twice. So 50 plus R and 50 plus r. Do you agree that's the equivalent of just squaring something? Okay. Now the other side, let's take care of it. R squared is just going to be r squared. What's 80 times 80?
6,400.
Good. It's 6,400. Now, when you FOIL, the F stands for first. So you're going to take the first to the first. That's F, right? O stands for outer. So outer term to outer term, the 50 goes to the R. The I stands for
Inner.
inner, so R to 50. And the L stands for the last two terms, which are R and R.
That's
Every single arrow in FOIL represents multiplication. So we are multiplying each of these terms. So check it out. It would be 50 times 50, which is 2,500. Then it would be 50 times R, which is
50R.
50R. Then we're doing R times 50, which is
50R.
50R. And we're doing R times R, which is
R squared.
R squared.
Whoa.
And on the other side, we still have R squared plus 6,400. Now, the beauty, if you did it the right way, you should have R squared on both sides. And they're going to cancel out. So they're going to subtract to give you 0. If you are left with R squared, you would be forced to solve a quadratic. I do not expect you to know how to do that. Are we all clear? R squared, if you did it the right way, should disappear. If it doesn't, you mess something up. Got it? Okay. So, do you guys agree that subtracting R squared from both sides is totally legal? I'm okay to do that,
Okay.
right? As long as we do it to both sides. What's R squared minus R squared?
0.
What's R squared minus R squared?
0.
Okay, so now let's just solve the rest of it. So we've got 6,400 equals 2,500 plus, what's 50R plus 50R? 100R. How would we solve for R? Good, subtract 2,500 from both sides. I believe you get like 3,900.
Yeah.
Yep. Equals 100R
Divide.
by,
100.
divide by a hundo. You should get R is 39.
So when you add the number and then the letter, it's always gonna be, you're just adding the number, not the letter. Like this.
Oh, like 50 plus R?
Yeah. You don't do anything with the R, you just combine the number.
Yes. So if we were multiplying them, right, then you would multiply the coefficients and multiply, like you would get R squared, right? But when you're adding them, you just add the coefficients. Good question. Okay. Do you guys see how my final answer did not involve R squared? Okay, R squared should go away. If it didn't, what do you know? You did something wrong, okay? Go back and check your work. Got it? Okay. Any questions on this first one? So the radius of circle C is 39. Cool beans? Okay, moving on. Example 3, I think we're there, okay? Name a line tangent to circle P, but not tangent to circle O.
What?
Name a line tangent to circle P, but not tangent to circle O. Guys, go ahead. Make sure that P is a dot right here. That should technically be in the center. Xavier?
Line BO.
B-O, very good. So we're going to write B-O, and I'm going to put a line above it. Why would this be wrong?
Wrong.
The letters are correct. Christian?
Huh?
Because it's in red. No.
I said it's a ray.
Oh,
Isn't it?
No.
It stops at O, or-
but it's asking for a line, right? With my notation, did I write a line? I wrote a segment. How do I make it a line?
The little arrow.
You have to put arrows. Did I not tell you guys notation was going to be super important? Okay? So a line tangent to circle P, but not tangent to circle O. Do you guys see how OB is tangent to circle P? It hits one point of tangency. I mean, if everything was like ideally right, but it goes through the center of circle O. So it's not tangent to circle O, okay? Now, name the common external tangent to circle O and circle P. Emma?
Line CD.
Excellent. And it needs to be a line, okay? Because remember, tangents are always lines unless they're specified as a tangent segment. Cool? Okay. Because do you see how D is a tangent point and C is a tangent point? It's external. How do you know it's an external tangent, guys? It's on the outside. If you were to draw a line between your two centers, did our line cross it? No, so it's external, okay? And then name the common internal tangent to O and P. Stephanie? Line A. Not D, though. E. Very good. Questions? Tangents are always lines unless specified otherwise. You guys got it? Is a secant a line or a segment? It's a line. Is a chord a line or a segment?
Segment.
Segment. Is a diameter a line or a segment?
Segment.
Is a radius a line or a segment?
Segment.
Is a tangent segment a line or a segment? Segment. Okay? A tangent on its own would be a line. Okay? All right. We're almost. Move on. Circle M and circle N are tangent at point P. PR and SR are tangents to circle N, and circle N has a diameter of 16. PQ equals 3, and RQ equals 12. What would PM be? Wow, that's a lot of information. So let's fill in our circle with what we know. We know that P is a point of tangency for both circles. PR and SR are tangents to circle N. So if they're both tangent to the same circle, what do we know about their lengths?
They're equal.
They're equal. By what theorem?
Ice cream cone.
The ice cream cone theorem. Do you guys see how both of these are tangent to the same circle? Therefore, their lengths must be the same. So PR is going to be the same as RS. You guys cool with that? By the ice cream cone theorem. It says circle N has a diameter of 16. So if we go from P to N, and then all the way through, this length is 16. Okay? So what's its radius?
8.
8. So 8 and 8. It says PQ is 3 and RQ is 12. So now how would we find PM? We're going to start with PM. That's this length right here. Now these dots are a little bit off. Well, do you guys agree that going from N to P would be the radius of circle N? And we know the radius is what? 8. It's going to be 4. Okay? Because if the radius of our larger circle is 8, that's the diameter of the smaller one, right? And so the diameter of this smaller one, how do you find the radius? You just divide it by 2, right? So it would be 4, okay? So each of these sections would be 4 and 4. So our PM is going to be 4. MQ.
Pythagorean theorem.
You have to use the Pythagorean theorem, okay? So it's going to be 3 squared plus 4 squared equals your missing length, we'll call it x squared. Okay, so then we've got 9 plus 16 equals x squared. This is going to be a nice Pythagorean triple. This will be 25 equals x squared. X equals
5.
5. Yeah, Jaden? Yes. What would PR be?
15.
Why?
Because you just add them.
Good.
Add PQ and QR.
One segment's 3, one segment's 12. You add those together and you get 15. So this whole length is 15. What would SR be then?
15.
15 because it has to be the same, right? By the ice cream cone theorem. So this one's also 15. What would NS be?
8.
Good. It's just another radius of that larger circle, which is 8. And what would NR be?
There's 17.
How'd you get that?
What? Because one side is 8 and then the other one is 15. That's the Pythagorean theorem.
Very good. We've got a right triangle in there, okay? We've got NRS as a right triangle. So we have to use Pythagorean theorem. We would get 15 squared plus 8 squared equals, you can label this y squared. 225 plus 64 equals y squared. And this is also a nice clean Pythagorean triple. It'll be 289 equals y squared. Take the square root and you get y equals 17. Wow is right.
We submit it.
Yes. No. These ones you don't submit yet, okay? On the last page, okay? Just for me, please write down 3 really important topics or 3 really important things from this lesson that you would like to take away, okay? 3 really important things that mean the most to you. What are the 3 important things to you?
From this lesson?
From this